Okay, today what we're going to talk about is equations for lines with a given point and slope, 6-5. Obviously, if you want an equation for a line given a point and a slope, you have to know a point and you have to know a slope. It says an equation of the line through any given point with any given slope can be determined with slope-intercept form of the equation. That's normally the general equation that we go to use. But there is an easier way, and we're going to show you that. When you have a point and you have a slope, there is a certain form you can use that will get you back to slope-intercept form. In lesson 6-4, you saw that it is easy to find an equation of a line if you know its slope, M, and y-intercept, B. This means that if you know the line slope and a point, 0, B, it had to be 0, B, where the line intersects the y-axis, then you can write an equation for a line. But what happens if you know the slope and some other point on the line? Not necessarily the y-intercept. This is often the situation as shown in example 1. So we're going to show you the long way here. Example 1 says, in 2006, the population of Alaska was 664,000. It was increasing by 7,800 people each year. Assuming this rate of increase means steady, find an equation relating the population of Alaska Y to the year X. So looking at this problem, 2006 is my X value. 664,000 is my Y value. My slope is a rate. Well, what's my rate in this problem? Well, 7,800 people each year is a rate. So my slope is, it's increasing 7,800 people per year. So my slope-intercept form says y equals mx plus b. Well, I know a y, I know the slope, and I know an x. I do not know a b. But if I know all these other ones, I can find my b. So I'm going to replace y, m, and x with these numbers right here. So y is 664,000 is equal to the slope, which is 7,800, times x, which is 2006, plus b. Well, we got to follow our order of operations. So the first thing we need to do is take 7,800 times 2006. And you're going to get out 15,646,800 plus b. We got to get b by itself because that's what we want to find is b. So I have to subtract all of this. Whatever I do to one side, I have to do to the other side. That minus is going to give me a negative 14,982,800 for my y-intercept. So now that I found my y-intercept, I can go right back up here to this problem and create my equation. Y equals, what slope? Slope is 7,800. X minus, because here's my B, minus 14,982,800. And we were able to get this equation because I knew my slope, and then what I had to do was find my y-intercept. Well, my y-intercept is at negative 14 million, almost negative 15 million, which is pretty far down. Something we would have not have been able to find on our calculator even if we wanted to. We would have never thought to go down that far to find my y-intercept. Okay? So you can see how it could be challenging to go ahead and find it on your calculator. But using this method, we were able to find my y-intercept, and since I had my slope, I was able to put it back into my slope-intercept form. Okay? Now, moving on. There's an easier way to find your equation of a line through point slope form. Now, Mr. Johnson does not call this H and K. He calls it X1, Y1. Okay? Now, for the book's sake, I can go ahead and call it HK. But the line through the point H, K, some point, with slope M has an equation y minus k is equal to m times the quantity x minus h. Notice h goes here, k goes here. It says either the slope-intercept method or the point-slope method of solving a problem like example 1 enables you to find an equation for any non-vertical line if you know its slope and the coordinates of one point on it. You have to know a point. You have to know slope. In example 2, we used a point-slope equation method to find an equation for a line whose slope and x-intercept are known. An x-intercept of a graph is the x-coordinate of a point where the graph intersects the x-axis. Let's go ahead and look at example 2. Example 2 says a line has slope, -5, and its x-intercept is 22. Find an equation for the line. Well, you know slope is a -5. You also know an x-intercept. Well, you only know an x-intercept when y you only know an x-intercept when y is 0. So, when y is 0, my x-intercept is 22. So the point that you actually know is 22, 0. It's very important that you know what an x-intercept looks like, what the coordinate point looks like. The number, 0, that's the x-intercept. If we had a y-intercept, it would be when x equals 0, so we would have 0, some number. Okay? Now, using that equation that they gave us, y minus k equals m times the quantity x minus h. Okay? This is m. This is my slope. This is h. This is k. Now all it's about is putting those numbers into your equation. So, y minus k. What's k? K is 0. Equals slope. What's slope? -5. Times the quantity x minus h. What is h? H is 22. This is your formula in point-slope form. We can turn this equation into slope-intercept form. The first thing you have to do is get rid of these parentheses. So let's do that. A negative 5 times x is negative 5x. A negative 5 times a negative 22. A negative times negative is positive. 22 times 5 is 110. Now what I have to do, remember slope-intercept form, you have to solve for y. So I need to move this 0 over to the other side. Well, the inverse of subtracting 0 is adding 0. When you add 0 to anything, you just get its self. So a negative 5x plus 110 plus 0 is a negative 5x plus 110. And now, by putting it into this equation, we found slope-intercept form. And this formula right here, point-slope form, is an easy way to get you to find an equation for a line given a point and a slope, and will easily get you to slope-intercept form. Why would we use slope-intercept form? Well, we would use it to put it on our calculator. Let's do that. Let's look at the next slide. It says when you find an equation of a line from a point and a slope, you can use a graphing calculator to check your answer. In example 2, the slope of a negative 5 and the point 22, 0 are indicated by the problem. Enter the equation you found into your y equals menu. We've all done this before, okay? We had to put it in a slope-intercept form in order to put it in our calculator. We've already done this. Negative 5x plus 110. To see if the point 22, 0 lies on that line, set up a table whose first x-coordinate is 22. The table shows that indeed the line passes through the point. So if you hit second function graph, scroll down to 22, is 22, 0 on that line? When x is 22, y is 0. Yes, then 22, 0 is a point that lies on this equation, y equals a negative 5x plus 110. That is all I have for you today. We will see you tomorrow.